Just let me start by asking a couple of questions. Can you put your hands up if you are, let's say, a customer or somebody who runs a parallel file system or something like that? And how many, put your hands down if, not yet, hands up again. Hands down if you don't have GPUs at all. Okay, every hand stayed up. One went up. I don't know how that worked. So what I'm going to talk about is XXIII. We're announcing it this week, and it'll go GA in a few weeks from now, so definitely this summer. XXIII is partly sort of revolutionary and partly evolutionary. It's an evolution of the exascaler platform. We're currently on exascaler 4.2, so XXIII advances that. But, you know, for a year, Andreas, say hello. Hello. Andreas and engineering team have been working hard on developing some sort of differentiating new features within XXIII from the Lustre team. I'm going to take you through, you know, the background to some customer conversations we've been having around AI and HPC, what that really means for storage, and then what we've been doing in XXIII to kind of tackle the problems that arise from those conversations. If I can find the right button. So this problem is one you all know. Who has problems with managing their capacity and get surprised by users who mail them and say, oh, I've just bought a new XYZ thingy and it's producing loads of data, can you give me some storage for it? This is a very common theme. The themes haven't changed, of course. This data volumes are going up really rapidly and always have done, but the rates always surprise. You know, every 6 months I get, again, surprised by the amount of data some thing's creating. We're really familiar with SKA, I think, and LHC as being, you know, huge data sources for large-scale analytics. And then more recently, we've got these new devices, new microscopes, nanopore systems that are delivering more data into life sciences. Again, I'll mention this again, but life sciences really is, you know, always at the forefront of analytics and data management. We've seen the DOE's published some papers on plasma physics and the huge amounts of data that's required during the simulations of, you know, modeling these large-scale plasmas in sort of quantum mechanical detail. And then again, talking about quantum physics, quantum Monte Carlo, again, stressing our systems like no other when we do these grand challenge applications. But then apart from these scientific instruments, now we have the AI instruments of data collection and inference coming in and adding to that pile. So we talk quite a lot to autonomous driving customers. They have been deploying systems at very large scale for the past couple of years. And typically, you know, what they do is they send these vehicles onto the streets. They're equipped with radar, LiDAR, camera data, cameras, and they're collecting around 200 terabytes a day. And that's one vehicle. And of course, in a city, there'll be many, many of these vehicles, so it's easily petabytes per day. And it's not just the fact you've got to ingest it, you've then got to do something with it. And on the other hand, we'll talk about this in a customer example. We've got these TV cameras and very high-fidelity cameras, which you need for doing real-time image analysis at scale. They're pushing close to a gigabyte a second in uncompressed data into a system for just one camera. And of course, the number of cameras out there is extremely large, and you'll see why that's going to get even larger the days to come. So no surprise, but I think always good to remind ourselves that this capacity problem and the throughput problem isn't going away. And then what's happening in HPC, and again, I don't think this is very contentious at all now. When I was doing my PhD, I was all in the red zone. We had a file, the input file was like a few K. It was literally the coordinates of some atoms. And then we put it into a very large supercomputer, the national supercomputer, and it's all compute. It was all compute simulation of the big craze in Edinburgh and Manchester. And then a couple of days later, I'll get another output file, and it'll also be a few K. It was like just the coordinates that came out. So put coordinates in, get coordinates out, no data at all to speak of. In contrast, life sciences have been doing data analytics at scale for a very long time. They really are the experts. They've been doing it in many differentiated kind of ways with many researchers developing all kinds of techniques all the time to do that data analytics problem. So right now, you know, for the past 5 years, this big data has come in and really augmented the problem space of HPC from simulations to simulations of data analytics. And then now, I mean, again, put their hands up, who's a customer? Or as running a system. who doesn't have any kind of AI deep learning appearing in their systems? Like, just one? You do. The chemists. Even the chemists could use some deep learning. So I say that because it really impacts numerical simulation and analysis. I mean, obviously it impacts analysis. It allows you to, at huge scale, particularly in cosmology, let's say, take very large images and find anomalous objects in there or find regular patterns, which you couldn't really find in other ways. But also it can assist in large-scale numerical simulation by really bypassing some of those pieces, like basically allowing you to do a different way of Monte Carlo, finding new routes, finding new sort of potential energy wells in your problem space quicker with deep learning. Okay, so part of the problem is set. Let's just look at 3 sort of customer examples who are really putting those kind of aspects into practice. 22 is a company, a partner we've been working with. We actually did a demo at Supercomputing. So you know now it's a real pain when you go shopping and you've got to talk to somebody at the end of it and buy your shopping or even use a scanner. So 22 is one of that sort of ecosystems of companies who's coming along to really automate that process and allow those companies who run your stores and supermarkets to give you a better experience by having those people, serve you in a better way rather than push things through a scanner. And they do that by having very high definition television cameras in the store, which are able to, in real time, analyze the products that you take from the shelves and then charge you appropriately when you leave the store. So it's this kind of thing that radically changes sort of what we need to do, because consumer stuff gets big very quickly. So as soon as this catches on, then we're going to see this spreading like wildfire across the world in terms of automated AI in our stores. And it provides a different problem for us. So now we've got to, cope with these, let's say there's 20 cameras in a small store. There might be 5,000 cameras in a large store, each one doing around a gigabyte a second. We've got to do live inference on that data. It's all a big problem, but now we've got to do it inside a store, not in your HPC data center. So that's a nice new challenge we have in providing simple, manageable systems that can really cope with this data at scale. We also need to do significant capability to support our customers. So this one will be announced this week. TOMMo, which day, Kurt? Tuesday, Wednesday? We'll find a press release. Today. So Tokyo Medical Megabank Organization who deployed a large XXIII system. And again, this is genomics, so it's always subject to the toughest of data analytics patterns. This one's at pretty serious scale, but the important aspect for this for me is that it's a real public service. And that means stability, uptime, robustness, and also a bunch of enterprise features allow you to do that, deliver that service very well. And then the last little example is more traditional HPC, sort of grand challenge stuff, but with a whole pile of AI right in there. So it really is AI HPC, as I've kind of been indicating for a little while. So TACC, the Frontera system, this is being installed today. It combines XXIII with IME. We'll talk about the XXIII characteristics and the capability characteristics it brings to TACC. On the IME side, if you look at that little graph, it kind of looks like I drew it, right? But actually I traced it from a real graph, and that graph you can find on the IO500. So if you go to I500, look at the hard benchmarks, then this little graph right here is basically showing you that IME is doing something radically different to your IO, and that's exactly why TACC wants to use it. So in combination with the capability of Exascaler, they get to use IME to help their really, really tough workloads really fly. So where are the pressures? Just to summarize, the pressures are data volumes are going up. In fact, the flash prices are obviously going down, and flash is definitely where it's at. We'll talk a lot about that. But hard drive prices are going down too. And so there's still going to be a few years left where at the capacities we've been seeing, we're required to do large-scale hybrid systems, right? It's not all flash today. It may be all flash in 5 years. That period between now and then still requires very strong hybrid capabilities. Performance across various aspects, and I'll talk about that a bit more. Uptime and user management. User management has been missing a little bit from the storage systems of today, and I'll mention what we've been doing there. User management really is getting an insight into what your users are doing live on a system. Rather than taking a systems approach, you can also balance that with but looking at a user behavior approach. And that's really helpful for many administrators in making sure their systems are behaving correctly and doing exactly what's expected. Meanwhile, the feature requirements, mainly driven from AI, are going up in terms of access protocols. Security requirements are continuing just stepping up. Every year we see a slight advance in the security requirements from even kind of standard HPC customers rather than the government ones where you'd expect those requirements to come from. And I'll talk a little bit about how we've been enhancing the security within XXIII a lot. And then, of course, multi-cloud, omni-cloud. So the public cloud vendors are becoming appropriate for some aspects of our HPC compute and AI compute lifecycle, and we need to be able to help you take advantage of that alongside the on-prem systems you have. So another complicated diagram, but that's just a really broad picture. We won't dwell on it. But now we've introduced AI, we've introduced security demands, multi-protocol demands, the demand for true and comprehensive data management. And then there's this edge problem over here. We've got to cope with this sort of strange ingest patterns of new and weird things, be scientific instruments or AI data collection. So there's all the demands. So what we're going to do about it with XXIII. So as I say, we're launching it in a few weeks, and I'm going to go through a bunch of areas. So the data protection, comprehensive security, full spectrum performance, improved user, particularly in workload management, and complete data management is all part of XXIII. And XXIII is launched soon, and it will continue to develop throughout the year with another release before the end of the year. I won't talk about this one because Sven's going to go heavy on performance and tell you all about that. What I will talk about is the flash management side. So we have enhanced exascaler, so it can perform FS-trim, and that's now connected with the back-end SFA system. So when you buy an exascaler system, you can perform FS-trim commands, and that means we'll do the garbage collection on demand when you want it, and it won't be interfering with your live workflows. So very strong feature, quite difficult to implement, and we've done it with our exascaler systems available from the middle of this year. Secondly, these AI workloads, they do something different from HPC. So a lot of it looks the same at high level, but a lot of it isn't the same. Particularly, we're strong on mmap, we're strong on container support, containerization of our exascaler and IME platforms, so we can deploy them inside containers very, very efficiently, including data isolation. Metadata operations are, of course, a big zoo of problem. It's not just one thing, metadata. It's shared directory, unique directory, and all the various calls associated with metadata. Been working on those. And small file support, and I'll mention how that's working in a few slides as well. So these AI workloads, they are different, and they need different tunings, and we've been doing those tunings. So many updates, patches, support have gone into XXIII to cope with these new demands of these new workloads. User and workload monitoring. So Lustre has been very differentiated for quite a while now, particularly exascaler, with delivering an ability to see the live workloads in the detail in a production system with many, many users. So you can have 1,000 users running simultaneous jobs, and your question is, who's doing what to my system when? And with Exascaler 5, you can drill down, look at an individual user and see what's that user doing in terms of metadata activity, in terms of throughput activity, which clients is he using, and how is that pressuring the system. And it's also very useful in debugging network issues, which are a common problem for us. So finding out where the bottlenecks are in a system, we can do that using our workload management system. And then user management with XXIII, we can also do that with the more, with just the file layouts. So we can ask the question for a user or a group or a whole file system, what's the file size distribution, what's the file count distribution throughout our systems. So now this comes out of the box, both the workload profiling and the file distribution profiling. All around security, we've taken, I think, a very good a set of steps in addressing security within Lustre. Within this system, we've, others have gone straight down an MLS route, like straight to the sort of hardest of government problems and tried to tackle that. We've really been listening genuinely to customers and saying, what do you need first? And the first thing really was multi-tenancy. We've got multiple groups. We need to give very strict and secure access to a subdirectory tree of our big namespace whilst maintaining the performance that Lustre gives us. So that came out about 2 years ago. But we've now enhanced that with a bunch of other security features. So we have multi-tenancy. We have full FIPS and KMIP support with an external KMIP server. Again, not needed for everybody, but we keep seeing new requirements for external KMIP servers to adhere to FIPS requirements in certain data centers. Access control, the ability to run Lustre on secure Linux for really extreme security requirements. And then we've also introduced an audit facility so that all accesses to files, inodes, metadata, and exascaler system, and all attempted accesses are all logged in a secure place to allow you to find out who did what when on the file system. We've also recently added formal support through Exascaler for NFS and CIFS, and we're just in the process, should be available pretty shortly, of renewing the support for the HDFS adapter as well. So increasing the number of protocols you can use to access an Exascaler system is definitely part of what we're doing. And you'll see later on, we're also doing some work on S3, so expect to see some news around S3 into Lustre also within the year of 2019. So coming very soon. We've done some very promising benchmarks and early work on that. So we'll be augmenting this slide with HDFS and S3 very soon. When you're doing things at scale, we need to protect that data at scale. And again, we've connected the dots in terms of the Lustre file system and the underlying platforms right down from the disk. So the application to disk, we're checksumming that data and doing that with extreme performance end-to-end for your application. So now you can switch on checksumming, the performance impact is going to be minimal, and you can be sure that what you read, what you write is what you'll later read. The biggest change we've done, so that's a bunch of stuff, right? But the biggest enhancement we've made to XXIII is build in a native scanning engine. It's always been possible to have an external database with external servers and start to collect data, which is essentially the data used to support all kinds of use cases like HSM, tiering, etc., and to be able to use other Lustre features. What we've done is really speed that up. It's extremely fast. It's in memory. It doesn't require external servers. So it's an extremely fast scanning engine that basically allows us to ask questions like which files are hot, which files are active, which files are least recently used, and also move that data between pools or create candidate file lists and handovers to HSM. So really this is a built-in data management engine which is now available within the Exascaler file system. And as I said, it's really an underlying technology. You will see this exposed, and we saw a graph earlier on about the file distribution profiles. That's being created out of this Stratagem file scanning system. So now we get real-time access to how the file sizes and the file distributions are changing because this efficient way of scanning the system is now available. But there'll be a whole pile of other use cases we can implement one by one over time to deliver on the demands of data management, user management, and multi-cloud out of Stratagem, right? So it really is the core piece which you've got to get right in order to do all those other things at decent scale with decent performance. Here's one example. So this one's hot pools. And we're combining hot pools with a bunch of other features. So Exascaler is really, we've got a lot of excellent ways of managing these hybrid systems at scale. And as I said, that's still a big requirement because hard drives are going down and our volume's going up hugely. So we still need to manage this hybrid problem at great scale very, very well. What you're seeing here is basically a hot flash area, which is fully scale out on the top. Then underneath that is an also scale out, very large capacity hard drive based system. And we're using two systems, two technologies within Exascaler to manage that data between flash and hard drive. And managing that in a sophisticated way really means the more sophisticated we are under the covers means the users don't have to care. They just run stuff and good things happen. Hot stuff is in flash, that's great. So what's happening here is we're using data on metadata. Fantastic Lustre feature, which means that all your small files automatically go into this metadata-based flash space. Not only does that benefit from being on flash, but it benefits from lower numbers of RPCs and therefore lower latencies, lower response times, because that data is going direct to the metadata rather than bouncing through metadata and to OSS and those RPCs. So supplementing that, we're also using Stratagem to manage hot data automatically between tiers of flash and hard drives. So as well as using data on metadata, we can take cool data from the flash area and pull it down into hard drives. And later this year, we'll be doing the same in the other direction, taking hot data that's appearing in the hard drive layer and automatically tiering that up to flash. But the important thing is this isn't happening at a little controller scale. This is happening really at a multi-petabyte scale, up to hundreds of petabytes. across distributed flash systems and distributed HDD systems. So, summary. We've been doing an awful lot of work. I think quite a lot packed into this XXIII release. Pretty exciting week it's going to be, and an exciting few months as we build out even more features, the S3, the HDFS, mature more of those use cases on top of Stratagem. We've been addressing strong data protection, comprehensive security, performance, and data management. And yes, please come and talk to us. Lots more to talk about these use cases. We'd love to hear, in particular, the challenges you're having and how we can implement this stratagem and build out new use cases with our external archiving and syncing tools to satisfy your use cases. Thank you very much.